series C for beginners. The next lesson is operators. The purpose of operators is to perform the manipulations with the operands. Operators are categorized into following. The first one is relational operators. For comparing purpose, you can use these operators. These operators are following: greater than, less than, greater than or equal to, less than or equal to, double equal to, and not equal to. And the second one is the assignment operator. Assignment operator. To assign any value to the variable, you can use this operator. And the next one is arithmetic operators. To perform the mathematical operations. These operators are plus, minus, multiplication into, divided by, and then modulus. This is for a remainder. Next one is the logical operators. To compare with the multiple conditions. Or opposition conditions. These are following. First one is and, it represents with the double ampersand, and two pipe symbols, it's represent or operator, and the exclamation mark for a not. And the next category of operators is bitwise operators. Bitwise operators. Here you can use bitwise and. So what for this bitwise operators instance? To perform the manipulations. With binary data. To perform the manipulations with the binary data like ones and zeros. So these operators are bitwise and represent with a single ampersand. And bitwise are represent with a single pipe symbol. And the XOR operator and a left shift operator and a right shift operator. So this bitwise operators plays an important role while working with any examinations, company specific examinations. In multiple choice questions, there are some questions comes into the picture. So I will explain in detail So if you want to work with these logical operators or bitwise operators, you must know about the truth table. That means based on the inputs, how the values are changed. If you're using a AND or 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 NOT or bitwise AND, bitwise OR or XOR operator. Let us say there are two inputs P and then Q. So in case of P and Q, what happened? In case of a P XOR Q, P XOR Q, what happened? And bitwise and bitwise are same as the logical and OR. So that's why I try to directly go for a XOR operator. Let us take the inputs are like this. If P is a 0 and Q is a 0, in case of P and Q, that means if both the conditions are failed, in case of P and Q it's a failed. In case of R also same thing. In case of XOR also same. And the second input will be like this. 0 and then 1. In case of AND, if any one condition is a fail, it will return 0. In case of OR, at least one condition is satisfied, that's why it will return 1. In case of XOR, it will return 1. And the next input, 1 and 0. So in this case also, one condition is a fail, that's why P and Q becomes 0, and P or Q becomes 1, and P XOR Q becomes 1. And in case of final, if both the inputs are positive, P and Q becomes positive, and P or Q becomes 1, and P XOR Q becomes 0. That means in case of XOR, if both the inputs are same, the output is a 0. In remaining two cases, it's a 1. Based on this table, you can perform the manipulations with the numbers and you can calculate according to that what happened. Here, for example, I will explain generally to check whether the number is even or odd. In previous lessons, I told if any number is divisible by 2, that means if I divided any number with the 2, if I are getting the remainder as 0, that number is called even number. That is a mathematical definition. But here bitwise, by using bitwise and also you can find out whether the number is even or odd. How that I will show with an example. Suppose I can take the number as 7. 7 is even or odd. 7 is even or odd. First of all, you try to find out what is the binary value for 7. What is the binary value for 7? So 0, 1, 1, 1, 2 power 0, 1, 2 power 1, 2, 2 square 4, 4 plus 2 plus 1, it becomes 7. So if you are using bitwise and any number, if you are using a bitwise and with any number and 1, if the result is a 0, that is even. If the result is 1, that is odd. So the binary value for 1 is 0, 0, 1. If you are using bitwise and, what happened? So you can get the values are 0, 0, 1. You are getting the values 1. So 7 is odd. 7 is odd. Again, I can take one more number. Some 12. 12 is even or odd. First of all, you have to find out binary value for 12. That is 1, 1, 0, 0. 0, 2 power 1, 2 square, 2 cube. 2 cube in the sense 8 and 2 square in the sense 4. 8 plus 4 it becomes 12. Between 12 and 1 if you are using a bitwise AND, for 1 the binary value is a 0, 0, 1. If you are using bitwise AND, so the result becomes 0. If it is a 0, so 12 is a even. 12 is a even. That's like this. You can use the bitwise AND. In some cases, you can use the XOR operator also. You can, based on requirement, based on problem, you can work with the different operators. So I will give one example on XOR operator. Generally, to interchange the values, previously I explained two methods, general methods. One is by using third variable, and the second one is by using arithmetic operators. In programming practice techniques, we will see that in programming techniques already we saw that for swapping numbers there are two methods, that is the problem 2 and 3. I explained using third variable, without using third variable. Here once you come to this language part, by using XOR operator also it's possible. So interchange two numbers by using XOR operator. By using XOR operator. Now I take the values. Number 1 is 6. Number 2 is 8. Now you can take the binary value for 6. For 6, the binary value is a 0, 1, 1, 0. For 8, the binary value is 1, 0, 0. Now I try to write the first expression, n1 equal to n1 XOR operator n2. So in this case, what happened? For n1, the binary value is 0, 1, 1, 0. And for 8, the binary value is 1, 0, 0. Between these two, if you are applying XOR operator, in case of XOR operator, what happened? If both the values are same, the output is a 0, and remaining two cases it's a 1, so that it becomes 1, 1, 1, 0. Now this is the n1 value. Again, I try to write the same expression for n2. n2 equal to n1 XOR operator n2. n1 XOR operator n2. In this case, what is the n1 value? The latest value for n1 is a 110, and n2 value is a 1000. Now between these two, if you are using XOR operator, what happens? So it becomes 0, 1, 1, 0. Now this is the value, decimal value for this binary number is a 6. Now one value is interchanged. Now we can write the same expression for a n1. n1 equal to n1 XOR operator n2. Now the n1 value is a 110, and the n2 value is a 0110. Between these two, if you are applying XOR operator, see what happened. So 1, 0, 0, 0. So 1, 0, the decimal value is 8. So you can display n1 and n2 value. This is another method. With the help of bitwise operator, you can do the manipulations. And come to the next one, left shift operator. In this case, what happened? The bits can be moved towards the left. based on the inputs they are given. For example, I try to take the decimal value is 8, 8 left shift 2. In this case, what happened? First of all, first step you have to take the binary value for 8. Generally, you are getting some for minutes, small numbers, you are getting the bits in a 4-bit format. If you don't want to change the values, you can represent in 8-bit format so that you can put the zeros before the actual binary number. So now this is a 8-bit format. So this 8 bits can be moved towards, so 2 bits can be moved towards the left. So in this case, what happened? How many bits are moved towards the left? Same number of zeros can be added at the end, so that you are getting the result as 0, 0. So this is, now in this case, what happened? What is this result? So this is a 2 power 0 value, this is a 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5. 2 power 5 in this sense, power of 2 is a binary, where in which position 1 is there in the 5th position, so that power of 2 power 5, it becomes 32. Indirectly, left shift operator multiplication. How it's possible, I will show. 8 is multiplied with the power of binary. How many bits are moved? 2 bits are moved. So that 8 into 4, you get it as a, you will get it as a 32. Same thing in case of right shift operator. Right shift operator, the bits can be moved towards the right, and the beginning can be filled with the zeros. For example, told right shift 3 bits. So in this case, first of all, you can take the binary value for 12. That is 8 plus 4. So 8 is a 2 cube, 4 is a 2 square, that is 1100. So you can represent, if you don't want to change the binary value, you can put the zeros before this. And how many bits can be moved towards right? 3 bits can be moved. So that what happened? You are getting a 0, 0, 0, 0, 0, 0, 1. No. Yes. 0, 0, 0. This 1 triple 0, 1 double 0 come outside, and 1 comes to here. Is a 2 power 0, that is a 1. So the result is 1. We are getting the 1 in the sense. Indirectly, right shift operator represent a division. 12 by power of binary value is 2. How many bits move towards the right? 3 bits. So that 12 by 8, you are getting the value as 1. Like this, you can work with the bitwise operators, right shift operator, left shift. So like this, the problems are given in multiple choice questions, and based on that, you can calculate and take the answer. Next comes into the picture. Next category of operators is unary operators. So first one is relational, and second one is assignment, and third one is arithmetic. and fourth one is a logical, and fifth one is a bitwise operator, and come to the sixth one, Unary operators. So in this case, we have different categories. Increment operators represent with plus plus. Decrement operators represent with minus minus. If you are using these operators before the variable, that is called pre. After the variable, that is called a post. For example, so based on the unary operators also there are multiple choice questions. For example, I try to define a variable n equal to 5. So I try to display n value like this. To display the integers, you can use a percentage d, and I try to use the post incrementation. In this case, what happened in case of post increment, once the value is displayed, after that the value can be incremented. So here you are getting the output as 5 only. After displaying the 5, it becomes 6. Suppose if the next statement, if you are using like this, percentage d plus plus n, already because of first statement, after displaying the 5, it becomes 6, and 6 is pre-incremented, so that here you are getting the result as 7. Again, I try to use the same statement, percentage d n minus minus. This is a post decrement. Still, the value 7 is displayed here. After that, it will decrement by 1. So if you display only one n value without using increment or decrement operators, here it will give the result as 6. Already 7 is displayed after displaying the 7 in the previous statement. Because of post decrement, 7 is decremented by 1, and come to the fourth statement, the n value is 6. Like this, you can use this increment operators, or in the single statement you can use increment and decrement. That's from right to left, the expressions can be evaluated in case of printf. And same thing in case of unary operator. The other categories of operators is shortcut notations for arithmetic operators. The syntax will be like this. Variable operator equal to value. Example, I try to define a variable n equal to 5, and I try to expression n plus equal to 10. The meaning of this statement is n equal to n plus 10. So that 5 plus 10, you are getting as a 15. Not only plus, you can use any operators, n into equal to 2. The meaning of this statement is n equal to n into 2, so that you are getting n value is 15 because of first, and 15 into 2 it becomes 30. Like this you can use the unary operators. And the last category of operators is ternary or question mark or conditional operator. Conditional operator. In this case, what happened? The syntax will be like this. So you can use the expression in the bracket and put the question mark and value 1 colon value 2. In this case, what happened? If the expression evaluates true, value 1 is written, otherwise value 2 is written. For example, here I try to define the variables integer n1 equal to 16 and n2 equal to 21. Now I want to display the biggest number among two numbers without using if, by using conditional operator. How it's possible? I try to display the printf statement. I try to display which one is the biggest, so that is integer values are going to display, so that I can use the percentage d. Here I can write this expression, n1 is greater than n2, question mark, n1 colon n2. In this case, what happened? N1 value is a 16 and N2 value is a 21. 16 greater than 21 is true or false. Because of it's a false, N2 is a displayed. So the 21 is the biggest number. Like this, you can work with operators. So some of these problems I will explain with the C editor. So regarding bitwise operators, so already I told bitwise AND operator. If you are using bitwise AND operator between any number and 1, if the result is a 1, that is odd. If the result is a 0, that is even. Now I try to check this. Now I take because still you are not going, still you are not learning this control flow statement. That's why I'm not using any if statements and then for loop. Simply I will explain with the help of a small number. Now I try to display printf percentage d and here you can display expression n and 1. So how much you get? Just you can check it. You can save this file. Already I told is a dev C++ editor. By using this editor, you can now work with C++ as well as the C. You can change the C source file. Give the file name. So bitwise operators. So you can use it as a bit1 example. And for component execution, you can use the function key F11. So it will display the result as 0. If it is 0, it is a even. You can check with another number. Instead of 8 you can take it as a 13. Same thing between 13 and then 1. If you're using bitwise AND operator, what happens? See, we're getting the result as 1. If it is 1, that is odd. So based on that, once you finish that, the next topic, that is a control flow statements, there you can work with the n number of programs by using a bitwise AND operator. And one more example I explained in the theory part, with the help of XOR operator, you can interchange the numbers. To create the new program, you can use the control N, and what are the variables you want, you can declare. After that, you can accept the values. At the time, if you want to accept, you can give the prompt according to that values for both the variables, so that the user can understand. The input is given in a single scanf. How many values you are going to accept? 2 values, so that you can use the 2 %Ds. Address of the variable of a first number, address of the variable of a second number. Once the values are ready, whatever the expressions you are written for a interchange, n1 equal to n1 XOR operator n2, n2 equal to n1 XOR operator n2, same n1 XOR operator n2. Once it's interchanged, in the next line you can display the result. To go to the next line, you can use a slash n, n1 equal to %d, comma, n2 equal to %d. Whatever the format you want, you can give it in a double quotes. And first %d value, we are getting the value from n1. For second %d, we are getting the value from n2. Once it's complete, you can save this program, give the proper name for this, source type as C, swap XOR. Now compile and execution, you can use F11. It will ask the prompting values for n1 and then n2. I try to give the n1 value as 16 and n2 value is 34. After running this program, n1 becomes 34 and n2 becomes 16. This is another example related to bitwise operator. Same thing, I will give one more example for a left shift operator as well as a right shift operator. That also I will explain with a simple numbers already, which are seen in a explanation in theoretical part. Now I can take the integer n value is 8. Without declaring the variables also you can check with simple. Printf %d, what's my requirement is I want to display. If you want to display clear manner, you can display 8 left shift 2 equal to %d. Here you can write expression 8 left shift 2. Printf 12 right shift 3 equal to %d. Here you can use the 12 right shift 3. Like this you can check. Now save this file. See source file. Left right shift. So 8 left shift to 32. 12 right shift 3 equal to 1. Both are displaying same line, so that you can use a slash n 1 so that it will display. Once the modification is occurred in display, 8 left shift 2. Indirectly, left shift operator represent a multiplication, right shift operator represent a division. That I already explained how it's possible with the multiplication and then division. So that's about the bitwise operators. And one more example I'll give for increment and decrement operators. So what happened, you can take it. Integer n equal to, I try to give it as a 6, 5. I try to display percentage d, or I can make the n value as a 6. So here I try to use n plus plus. In the next line, I try to display. So because of this, what happened here, it will display 6. Here I try to use after displaying 6, 6 becomes 1 is incremented, it becomes 7. Here I can use a plus plus n. Here it will display the output as 8. Printf slash n percentage d. Here I can use a post decrement n minus minus. Still it will display the output as 8. After that I try to display printf slash n percentage d. This time I display only n value. So this in the third statement of printf, the 8 is decremented by 1, so that here it will display the n value is 7. So like this you can work with the increment or decrement. So 6887. 6887. So like this you can work with the increment operators and then decrement operators. I'll give one more example. For I try to display biggest number among two numbers. The biggest number is percentage d. Without using a control flow statement, so conditional statement, you can use a conditional operator. N1 greater than N2 question mark N1 colon N2. So it's a ternary operator. So the biggest number is a 21. Like this you can work with the operators. So this is a previous output. I'll close all the output windows, and this is another output window close. This is another output window close. So that's all about the operators and then examples. And in the given description, I'll give my blog link. Just go through the same content is displayed with the proper examples. If you are unable to follow this video, or if you have any doubts, once again if you want to clarify with the running text, better to follow that blog.